Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So today I'm going to look at the graphs of trigonometric functions, and this of course is an aspect that is going to complement on the number of videos that we have discussed on the same. Particularly for today, this is going to have an analysis of basically the change in amplitude or the change in what we refer to as a phase shift. And this basically are going to entail horizontal shift and vertical translation. Now, in a specific case that I've given for the values of the function y is equivalent to the sine of x plus d, these two graphs are going to be basically the vertical translations of the graphs that we have done for the sine of x and y, the cosine of x, respectively. So for us to try and to consider this specific translation, as we said, if we change an amplitude or the graph of a function a, the sine of x, whereby a implies amplitude. Now, in this specific case, we had said that we're going to represent an amplitude for the change in either positive or negative y using the absolute value of a. Now, in that specific respect, then therefore, we're going to consider this vertical translation of a d in terms of a d units. And this is going to be given as either the positive or negative values, but we're going to consider this one generally to represent what we refer to as a vertical translation, as I've said. Now, for us to just understand this specific concept, we are going to consider a general case for the graph of a sine wave, which is represented, as we have discussed from our various videos, as y at the sine of a b, and then we're going to have x minus c plus d given as such. So we're going to have this general representation for the sine of a function using this general case for representation of a sine wave. And of course, we are going to see that from this, we defined the concept of an amplitude as the absolute value given as a. So it's going to appear in this specific part of the sine wave given as such. So this is going to represent what we refer to as an amplitude. And in this particular case, we talked about the concept of a horizontal shift. And this horizontal shift is going to be this particular change of this particular argument from x minus c given as such. And this is going to represent what we referred to as the horizontal shift. And then I talked about the concept of a period. And in this case, we had given a general representation for a period as a value that is the ratio between 2 pi and this particular value for p. And this is going to be describing our period from this general illustration of a sine wave. And then lastly, we're going to have this value for d representing what we refer to as a vertical shift, a vertical translation. And this is going to be our general point of emphasis in this specific discussion. So suppose I give an example. Of course, it's going to give us an elaborate way of understanding this specific point, whereby if I consider the graph of a function of y is equals to the sine of 3x plus pi, and this is going to be plus 1 given as such. So for me to have this version of this graphs that is going to, of course, give me an aspect of what I referred to as the concept of a period, then therefore I'm going to write it in a format that is going to assist me, of course, obtain the value for p as given from this general illustration. Therefore, I'm going to have this particular function given as y is equivalent to 2 the sine over 3x plus pi over 3, and then plus 1 given as such. So I've introduced this specific factor for 3 in order to, of course, imply the function of this, or rather the value for this particular value for p, which is going to assist me obtain the value for a period. So then therefore I can be able to illustrate these specific values, whereby I'm going to have the amplitude given as the absolute value of 2, which is going to be 2 given as such. And for the period, then therefore I'm going to have my period given as 2 pi over. So this value for 3 is not going to have an effect since it's going to cancel out. So this is going to be given as 2 pi over 3 given as such, and that's going to represent my period. Now to describe the horizontal shift in this particular case, which is a value for this particular case for the value of c, I'm going to look at this specific value in collaboration with this value for c. So it's going to be the negative value over pi over 3, and that is going to represent my horizontal shift. And of course, lastly, I'm going to consider the value of a vertical translation, which is going to be giving me the values over this specific units that gave us d units, and these are going to give me the vertical translation. So in my specific case, I'm going to have the numerical value for a representing what we refer to as a vertical shift, and this is going to be given as 1 given as such. So then from this particular illustration for the concept of the graph of the sine of a function given as such, we can be able to describe these particular translations, vertical translations for the graph of the sine and the cosine of x given as such, by considering the translation by these d units, whereby d is going to represent a numerical value given as this specific example that I've given in this particular case. Now, this basic description is going to assist us, especially in trying to interpret various graphs that we may obtain from our plots or other various question sets that we may come across, which are consisting of graphs of this specific nature. Then, therefore, we're going to see that from the general illustration of this particular equation, we can be able to describe various aspects of either amplitude, horizontal shift period, and vertical translations, which are going to assist us, of course, do analysis of various graphs. So that is it for now, guys. But of course, I had mentioned in our last video that also we're going to describe the concept of a frequency, especially in its various aspects of application areas. Now, basically, the frequency is going to be described as in a sine function. Of course, we're going to see that the period is going to be given as Pierce have said, and of course the relationship between this specific period and frequency, we're going to see that period is going to be the inverse of a frequency given as such, and we're going to see other laws, especially in some of the discussions we have had. Kindly check in our description box for other related videos, especially which are going to give an elaboration on this specific aspect, especially for the last one that I've mentioned. So that is it for now, guys. Bye. God bless.